Solve this exciting physics problem about energy conservation. So here we apply the conservation of energy and the work theorem with the spring and the gravitational potential energies. So here on the diagram, as you can see, we have a car. So this car is loading down and colliding with a spring. So in our video today, I'm going to discuss how we are going to solve this question step by step. So before we start, you have to know the concepts which are involved in solving this question. So the first concept that to apply is the conservation of energy. So that law states that matter can neither be created nor destroyed, but it can be transformed from one form of energy to another form. So here we'll see the conversion of gravitational potential energy into kinetic energy, then later on to be converted into the spring potential energy or the elastic potential energy. The second concept we use is Newton's second law to determine, of course, the acceleration at which the spring stopped the car. Then, last but not the least, we are going to talk about the work energy theorem. Work energy theorem, we are going to use this to calculate the energy which was lost due to friction, sound, and other factors. So, without wasting much of your time, we'll begin. So let's go to where I'm solving the question. Okay, so here is the question. A 3,000 car starts at rest and rolls down a hill from a height of 10 meters. It then moves across a level surface and collides with a light spring-loaded guardrail. So first, A, neglecting end losses due to friction and ignoring the rotational kinetic energy of the wheel. Find the maximum distance the spring is compressed. Assume a spring constant of 1.0 times 10 to the power 6 newtons per meters. Then B, calculate the maximum acceleration of the car after contact with the spring, assuming no friction losses. Then C, if the spring is compressed by only 0.30 meters, find the change in the mechanical energy due to friction. So the first one, we are going to apply conservation of energy. You should be remembering these concepts. So physics is more about knowing the concept than knowing the answer. Yeah. So you have to show them the process. The final answer on the card is 1 mark. If the question is saying, for example, calculate, if the question is 10 marks, always the final answer will carry 1 mark. So if you just remember the final answer, you may get 1 mark. If you are unlucky. So I'm going to start by solving now the first one, which we are going to calculate now the maximum distance the spring is compressed. Yeah. So first thing we are going to do is to right now as the data. So what do we have? First, we have the weight, which is mass times the gravitational field, which is equal to 13,000 newtons. So this is the formula for weight, don't forget. Then next we have the height, which is 10.0 meters. So the height has given us how many significant figures our answer should have. It should have 3, like this. Next thing is we have the spring constant, which is 1.0 times 10 to the power 6 newtons per meter. So for it to be easy for you to calculate, you multiply this to 1 times this, you simply get 1, 2, 3, 4, 5, 6. Yeah. So 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Yeah, so you get this. So this will be easy for you. But remember, the answer should be in either this or this. So the final answer should either be in decimal point. If not specified, you can leave it in scientific notation. So now let me draw a diagram. Since that one I've removed it. Yeah. Okay. So here is the spring constant. Then the car is here. Then you have the height of the cliff, which is 10.0 meters. Then you have the weight of the car, which is 13,000 newton. Then you have the spring constant of the spring, which is 1 million. Yeah, 1 million newtons per meter. So now here you are wondering which equation now to use. So the conservation of energy, it also states that the energy can neither be created. So basically we have 3 types of energy. We have the kinetic energy, the elastic spring constant energy, and what? The gravitational potential energy. In this question we have only 3. So the conservation of energy states that the initial gravitational potential energy, which is presented by this, plus the kinetic energy plus the elastic potential energy, initial should be equal to the potential energy plus the kinetic energy plus the elastic potential energy 5. So this is the formula. So the initial energy should always be equal to the final energy. That's the conservation of energy. So now, when the car was at the cliff here, the car is not a spring, so it didn't have what? This, the elastic potential energy. So the elastic potential energy will be 0. 2, the car was not moving, the car was at rest. So which means it didn't have also what? The kinetic energy. But the car was on top of the cliff, and the cliff was 10 meters. So which means it had gravitational potential energy. Remember, gravitational potential energy is the energy due to the height of an object. So any object which has height, or any object which is placed above or elevated, it should have always the gravitational potential energy because of the height. Okay. So the formula for gravitational potential energy is mgh. So this was initially when the car was at rest. Now, since they are saying in the question that find the maximum distance the spring is compressed after the car hits. So when the car hits the spring, for the spring to be compressed maximum, the car should stop again. Because if the car is moving, the spring will continue being compressed. But when the car stops, the spring, when immediately the car stops, the spring will also reach the what? The maximum. Or when the spring reaches the maximum, it will stop the car also. Because the spring has reached the maximum compression and it cannot be compressed anymore. So it will stop the car. So what am I trying to say? I'm trying to say that at maximum distance of the spring, when it's compressed, the car also doesn't have kinetic energy because it's going to stop. Then, since this is ground level, and when the car reaches here, we don't have any height. Also the height, as the car is rolling down, the height will also keep on reducing. So here, since we don't have any height, which means we also don't have the gravitational potential energy, but we have now the elastic potential energy, since the spring was now compressed maximally. So here, the potential energy which was tampered with was the one which was stored in the spring. So here we are going to say potential energy of gravity is 0 plus the kinetic energy which is 0 plus this potential energy which is half kx squared. So this is the formula for the elastic potential energy. So now we'll eliminate these zeros. We'll remain with mgh is equals to half kx squared. So here, since we don't have the mass and the gravitational field, but we are given the what? We are given the weight. So since weight is mg, so where there is mg, we'll put what? 13,000. Since mg is equals to weight, so we say 13,000 Newton multiplied by the height we have is what? 10 meters. Then should be equal to half the spring constant we solved. It was what? 1 million. 1, 2, 3, 4, 5, 6, yeah, 1 million. Then we are looking now for the maximum distance the spring was compressed. Yeah. So if we multiply 13,000 times 10, we'll get what? 130,000, which should be equal to 1 million. 1, 2, 3, 4, 5, 6 x squared, then divide by 2. So basically here what I did, I multiplied 1 with everything that was on top, then the 2 Just became the denominator. Then here you can cross multiply 2 times this, you get what? 0, 0, 0, 0, 6, and so you get 260, which is equals to 1 million. So this you can do if you have a calculator to 1, 2, 3, 4, 5, 6. So for the first, then you divide by 1 million. Even here you divide by 1 million. So when you divide, you get x squared should be okay. So I went to solve. So since I don't have the calculator, so when you divide this, you get x squared should be equal to 0.26. Then you find the square root of 0.26. Then you get x should be equal to 0.509 meters. But remember, our answer should be now many 3 significant figures. So you need to round off this answer to 3. So you count 1, 2, 3. So since the next number is above 5, so you add the 1 to this, and your final answer for A becomes, so x is equal to 0.51 meters. So this was the distance the spring was compressed by the car as it hit the spring.